Right, that's the question. How can an
So
element? Yes, go
so
ahead.
when the
Go ahead.
iron has a positive charge, sir,
Yeah, but what causes it to have a positive charge?
Because the proton numbers are not equal to the
Come
electrons.
on, you're saying the same thing over and over again. That's the same thing we say. We already say the proton them are go more than the electrons. I'm asking you why that happens. How does that happen? That's the question I'm asking. How does that happen? We spoke about it on Wednesday. To ask you how does that happen? That means that nobody not going through the notes, or even if you go through it, you're not looking at it properly. One simple word you need to answer me. One simple word where you don't have in a vocabulary from kindergarten, from basic school. Just one thing you need to tell me. Why does why does that happen? Why does an atom or why do some atoms end up with more protons than electrons? One simple word you need to tell me. All right. Let me show you how simple that word is. What's this? What's this word?
yes, sir.
Glass. Simple four-letter word. I can't remember. Just tell me say lose electron. That's it. Electrons are negatively charged. So if it lose them, then it will end up with more positive charge. Why? Because the neutral atom have equal number of protons and electrons. But if it loses electrons, then more protons going to leave back. Everybody understand that?
Yes, sir.
Yeah. So the same thing. The same thing like if you have money. Yeah, if you spend more than you get, what's gonna happen to you? You spend more than you get. Will you be a rich person or will you be a poor person?
Or
Of course. Can you go owe somebody? Where you get it to spend? Must borrow. Or thief. All right. Same thing there. So same thing we can apply here. You have persons who what? You have persons who spend less. So them have a whole heap of money, but then spend less than them earning. Does that apply to anybody in this class? Wanna try to spend less than wanna have? As in, if you have $100, you try not to spend half the $100. Or if you have $1,000, you try not to spend half the $1,000.
Depends on how you buy, sir.
Depends on where you're
Depends.
buying. All right, fair enough. All right, depends on what you're buying. um, you know, I like when you say that because there's a reason why an atom becomes an ion. Right? The reason why the atom wants to become an ion is that it doesn't want to be alone. It wants to bond with something. So if a neutral atom, what you see on the screen here, that's the atom that God make on the periodic table. So um if it have one, so if he made it with one proton, it's gonna have one electron. But then if that element with the one electron and the same one proton decides that I'm gonna give up an electron, what it means is that we have any, and it's gonna become an ion. Now the thing is, if it gives up the electron, it has to give it up to some other element that wants electron. All right, it can't just give it up and there's nobody to give it to. All right, the same thing. Same concept here. So you give it away, all right, fine, but then there has to be somebody to receive it. And so in chemistry, that's how we end up with this thing called bonding. And because of bonding now, we have compounds. And compounds are chemicals that, well, let's just say they have two or more atoms combining together. All right, to form many things on Earth, including water, which is an example of a common compound. Everybody should know about water. All right. Anybody knows the two elements that make up water? Hmm? Microphone not working? Nobody knows the two elements that make up water. Okay, that's nice. Anyway, let's move on. So the word I was saying was loss. All right, loss is the word. All right. So how does an atom end up with more, right, protons and electrons? The reason is that it has to lose. All right. So let's go back to this diagram then. What I'm seeing here is the proton them increasing as you pointed out. This one now. Notice that on the outside shell, what color are those electrons?
Red, sir.
Red. Anybody can guess why they are red? Why they weren't black like the ones on the inside shell?
So because they're not needed.
Because they are not needed. I like that. I like that. That's a good answer. Because they're not needed. um, and you're correct, You're correct. Uh, they're not needed. They are extras. Thing about it is, I would say to you that some elements need them though. The ones that have more electrons on the outside shell, they need those electrons more than those that will have only one or two or three. So let's check this out now. Hydrogen has one, so yeah. Does it really need it? No, well, hydrogen tends to give up that electron as well as it can get another electron. To hydrogen has the ability to gain electrons. If we go back to this same image here, hydrogen does have the ability to gain electron because hydrogen only has one shell. And remember that first shell can hold up to how many? How many electrons maximum can hold on the first shell? Mm,
Two, sir.
Two. All right. So two electrons, the maximum can hold on the first shell. All right. So hydrogen has only one. So what it means then, probably let's bring up a hydrogen atom to show you what's happening. That's hydrogen. Right. So let's go to the atomic structure. Yeah. And to show you guys this image. All right. Let's move that. Why is this not selected on? All right, there you go. So look at this now. This is the structure of hydrogen. Let's all right, and let's increase the size here. All right, so everybody seeing the hydrogen atom here, right? So have you seen it?
Yes, sir.
All right. Let's show you something else now. That's the hydrogen atom like using this one's okay. Uh, all right. And I want to also show you this diagram as well, because this diagram is telling you a lot of chemistry here that's happening. So that's our hydrogen atom, and then of course it's this thing is a big. Let's crop it. All right, there we go. All right, let me show you something now. Crop here. Yeah. So this is hydrogen, guys, and this is how hydrogen behaves. Again, it's if it loses an electron now, it becomes the hydrogen ion. Um, literally, and say here electron deficient here means that it's lacking electrons. All right, so there you go. So here is H plus. We realize that hydrogen ion is actually written as H plus. So in chemistry, when we write, when we are representing ions and we are referring to specific ions, we have to use a plus or a minus sign beside it, beside the symbol, right? Because the symbol and the plus or minus sign tells you like how many electrons it lose or how many it gain. All right, so here is the hydrogen ion, all right, because it loses, all right, the electron. Now, hydrogen can also gain an electron as well. Again, it depends on the situation it is in. All right. So um it's so it basically coming like anybody in here playing netball? The girls, I know O'Neill probably don't play, but Ruda, Abigail, Tiana, Sasha K. And yeah, you play netball?
No, sir.
Yes, sir.
Sir.
Abigail, oh you play netball, Abigail?
Yes, sir.
Okay, that's good. Um you're playing on my shift, so that means who is your so Miss Green is your coach then?
Yes, sir.
Okay. Tiana, you play?
Yes, sir.
Okay, lovely. And Sasha?
No, sir.
No? Okay, no problem. All right. So when you're playing netball now, Tiana and Abigail, right? Do you play the same position all the time?
No,
No,
sir.
No. So the positions on the court are different, right? So can the center shoot the ball in the hoop?
no, sir.
Okay. You realize that's what's happening now. So in other words, when you're a center, you get the ball, you pass the ball. But when you're a goal shooter now, you get the ball, usually you shoot the ball. So,
Yes,
so
sir.
same
Yes,
thing.
sir.
Same thing. So in the case of hydrogen now, if it needs to, if it's beside an element that has extra electrons in, and element that have extra electrons, let's go back to that diagram and show you how an element can end up with extra electrons here. Um, when you have a shell, right, that is incomplete, right, those are considered extras. So that's why the outside shell of these elements have red electrons to show that they can be lost or they can be gained. They are vulnerable. Red means danger. So the element is in danger of either losing those electrons. Um, in fact, yeah, they are in danger of losing electrons. However, what we're going to realize is that, all right, so lithium has only one, so lithium can lose that one easily. All right. Beryllium has two, so it has to lose two. As Tiana said, they don't need the extras then. So, all right, so beryllium, that's Be. And I hope everybody know the periodic table at this point because I'm not expecting you not to know the first 20 at least. The first 20 is important. But we have our boron here. Then we have our carbon, right, which has four. So there's a rule here. Um, So the more, all right, let's start with saying the less. The less, by the way, the red electrons, and I should point out that before I start anything else with you guys, there's a name given to the electron that you're seeing in red in this diagram. All right, there's a name given to the last shell as well. All right, so the outermost, all right, electrons are called, all right, are called valence. All right, what is that? This word?
Yes, sir.
Yes, sir.
Yes.
All right, so the outermost electrons are called the valence electrons. All right, now, so the next thing, what are these good for? Valence electrons are used, you could say they are used to communicate with other elements, all right, by exchanging them. All right, so the valence electrons are exchanged between atoms in many cases. All right, so that is where chemistry begins, guys. You start by learning the element, all right? Then you learn about the element, you realize them have atoms. No, they have atoms. Atoms have electrons. And then when electrons are traded between elements or between other atoms from other elements, then they will have all these beautiful things happening. All right. Sometimes every time an element gives away electrons or accepts, where it give away or takes away electrons, there is a physical evidence to it. It's like, for example, you are adding, everybody ever add bleach to like a bright color clothes? But ever do that accidentally?
Yes, sir.
Yes, Abigail. Confession is good for the soul. All right, so you spoil your clothes, right?
Yes, sir.
Yes, man. No afraid for talk. We all go through some of those rough times then. But all right, fine. You spoil your clothes, bleach, liquid bleach, get it. What happened to the clothes when the bleach touch it?
Sir, the color change, sir, get lighter.
Get lighter. All right, guys. Let me tell you something. I'm going to leave you with this tonight. In today's class, right? Whenever you see bleach poured on fabric and the color of the fabric change, right? It is because the bleach actually has taken away electrons from it, the clothes. All right. Every time electrons are taken away or added to something about the object that it is in change. So let me show you another example then. All right, let's show you something else. What do you use to cook your food? What is the main tool you use to cook food? Without it, you can't cook food. What is it?
Sir, pot.
Pot? Hold on.
Sir, water.
Water? Hold on. Hold on. I can't understand these answers.
Put the food in the cookie, sir.
Hold on. So hold on. Me ask, hold on. Hold on. Me start it. Tiana, you're saying that if you don't have pot, you can't cook.
No, sir.
All right, I'm saying that.
I cannot have stove or fire, sir.
No, but that's you're supposed to say that first. Say that the one first. You tell me fire. Well, tell me about other something where you can do without. Someone no need for going and carry it and live some rough life.
Sir, so how you go cook without one pot?
I mean, you know, stick, put a catch sauce on rat and just push in a stick in him and then hold him over by fire and roast him. You can do that.
Sir, you
Sir,
can't.
why you eat rat?
Because times are hard. That's the thing. If you are in a wilderness, then there's nothing and you have to survive. What you gonna eat? You gonna stush?
Bird.
Sir, understood,
Bird.
sir.
All right,
Nice.
fine. Is a bird easy to catch in the wild?
No, sir.
No. So, but then rat eat have to catch and bird. No, so.
Me not eat no rat.
Hmm? You
I'm
know,
not
I eat it.
afraid of rat.
No, but the thing is life and death. What I try to get here is this: that you use fire to cook food, regardless of every other way, other things you use. The fire is important, right? Whether gas stove or whatever the source is, or coal fire, right? What I'm trying to get here is that to light a fire, you need to do something to the gas or to the coal, right? Now, what do you do to the gas in order for fire to happen? Right? To get the fire, what do you do to the gas? You turn on the gas, does fire come up right away?
No, sir.
No, sir.
Sir.
No. So what do you
Yeah,
have to do?
so
Yes, O'Neill.
you put the fire near the bunch, near the burner, sir.
You put the fire near the burner. All right, good, good. And that does something. What do you do to get that fire in the first place to go near the burner? You do something.
Sir, you connect the gas to the stove.
Well, you connect the gas to the stove, and the fire does happen when you do that.
Sir, you connect the gas to the stove, sir, then you turn on the stove and use
Mm.
the lighter, sir.
Use a lighter. And how does the lighter work? Did the lighter have fire in it when you take it up?
Sir.
No,
No,
yeah,
sir.
you're missing out something. You're missing out a detail. What needs to happen to the lighter to get fire from it?
Then I have to strike you lighter.
Strike. Very good. Strike. That's the word. All right. Striking objects is a way of is actually a way of exchanging electrons, really. When you rub something, electrons are moved. The electrons are on the outside. If you notice in these diagrams here, the electrons are on the outside. But you see that? They're on the outside of every material you can find. So once you rub a material, you're actually exchanging electrons. So what
But
you're
sir,
doing the yes, go ahead, O'Neill.
sir, and every time, sir, you got, sir, and every time you got have lighter or matches or something like that, sir, for light fire, sir.
Good. So what else can you use?
Sir, stone.
Rockstone, yes, some stones, not all, but some can use. So
So
that's why I'm
even the sunlight, sir.
what's that?
Even the sunlight, sir.
Sun I can use. Yeah, that's true. But what does the sun have? Why is the sun so hot?
So you can use like a glass, then set the glass of the
Mm.
direction of where you want to set the fire, so then the sun will just shine through.
Yeah. Well, all of what you're telling me is what you're doing. It's electrons you're using up in you're passing electron. When the sun shine from where it is to and to earth to us and our skin, there's electron transfer. Electrons are leaving something. I want to leave you with this question. All right. What two elements are found on the sun? There are two elements, only two elements that are found on the sun. Which two are those? All right. Those two elements are responsible for all the others. That's why people used to worship the sun. All right. So, and that's back in the ancient days. All right. The sun has two elements. All right. These two elements, all them do to create the sun is them exchange electrons with each other. Every time an electron is exchanged, electrons move so fast that they move at the speed of light. And then because they're moving so fast at that speed of light, then what? We are seeing light. That's how it works. So anytime you see light of any form, does no says electrons are there. That's the evidence of electrons. All right. So I'm leaving you with that information, guys. All right. Everything you see around you is based on electrons being exchanged. All right. Valence electrons to be exact. These are electrons that are on the outside of atoms and they are available for interaction. All right, guys. So Remember that question I had asked you?
Sir, hydrogen and helium are found in the sun, sir.
Well, there you go. So it was as simple as that to find out the answer to that. Remember, we still have this question to answer. Um, three elements will not form ions naturally, and the reason why that happens, that those elements that you were in tell me are found from 1 to 20. Still don't answer that question yet, but I realize that I probably need some more information to help you find it. So we're one step closer. All right, but it seems to be break time now, so I won't go too far into it. Right, but just understand this, guys, that the main thing I wanted to leave here today is understanding what are valence electrons, right? And also you should be able to tell me, in fact, you know, when you leave with this, right? So determine the valency, and this is a term that you're going to see a lot. It's some real chemistry now. So um what are the valency, all right, and valencies of the following. No,
So
yes, go ahead.
surveillance is spelled VALENCE. Sorry,
Um,
CC.
CES,
Said VALENCE.
valency.
So,
Um,
say so right now. So because I was searching for it, so
mhm.
and it's spelled VALENCE.
Let me see something here. Yeah, that's where it come from. The word available. Which is but hold on a sec. You sure about that? Because I'm seeing EN. Oh, it's E. Yeah, sorry, that's a mistake. Actually, this is valence. Yeah, that's actually a French word. Sorry about that. Yeah, very good. Pick up Tiana. So there are what are the valency that are following atoms? Um, and then let's give you these atoms here. We have our, well, let's see. Let's go with the common ones they'll ask you. Mm, all right, and then of course looking at all right, and of course, so this word you need to know what it means and give me these answers. All right, and yeah, so this is a question of the day. All right, so what are the valencies of the following atoms? So you can find that by looking on the diagrams and just counting. All right, so remember that valency, the word valency actually means valence electrons. So let me put the A there because I'm thinking about that French word, that beautiful French word. All right. So there you go. And then of course, let's see. I've correct those. And we save that one. All right, guys. So that's it for today. All right. Need to show you how the ions are formed, and it has to do with the valency, how many it has available. All right. So I will send these notes in the group, in the classroom rather. And I'll see you guys next week. Is it next week, Wednesday?
Yes, sir.
All right. Hold on a sec. Let me get this register out of the way. Today is the 23rd. And yeah, certainly need to change the color here. Yeah, today is the 23rd and the 4th. And not many persons here today. I think there were some internet problems for some persons. And let's just remove these names and add I'm not seeing Crescente, but Abigail is here. Let's zoom out so you can get some space here. All right, so this will be out as well. And carrying this over here. Sasha K, you're here. So I need to write down your name. All right. All right. Yeah. All right. So again, different homework, but this is a register. All right, guys. So that is it. All right. So let me just switch this here. Homework on that page, information here. All right. So all right, guys. So you can just look out for this in the classroom and enjoy the rest of your weekend and stay safe. All right. So some expose here. All right. So all right. So this is some two. All right. So